Okay, so what we're going to do here is we're just going to walk ourselves through one round of the cardiac cycle, and we're going to do this from the perspective of the pressure inside of either the left or the right ventricle. It doesn't really matter which one we're talking about because the ventricular myocardium is going to all contract and relax at the same time, so the contraction and the workings of the left and the right ventricle should happen simultaneously. So where we're going to start with is we're going to assume that we are starting in ventricular diastole. So the atria are currently in the process of contracting and adding a little bit of volume of blood on top of the end diastolic volume. But at this point, the ventricles are relaxed. So the current situation is that the pressure inside of the ventricles is actually lower than the pressure inside of the atria. And this is what allows the atria to deliver blood into the ventricles. Blood always flows from high pressure to low pressure, so at this point blood is coming from the atria to the ventricles. So what we're going to see here is the ventricles are just going to start contracting. The pressure goes up a little bit as they fill up with blood, so the pressure in the ventricle is going to start to come up here, and eventually it's going to get to the point where the pressure in the ventricle is actually higher than the pressure in the atrium. So this is going to be event number 1. So over here, this marks the beginning of ventricular systole, and because the pressure inside the ventricles is now higher than the pressure in the atria, the atrioventricular valves are now going to close to prevent blood from flowing backwards from the ventricles back into the atria. So at this point, both the AV valves and the semilunar valves are shut, but the ventricle is starting to contract. So this is going to produce a very large increase in intraventricular pressure, and this is what we refer to as isovolumetric contraction. This is event number 2. So isovolumetric contraction is only possible if both the AV and the semilunar valves are both shut and the ventricles are in the middle of systole. So because both valves are shut, the blood inside of the ventricle has nowhere to go, and that contraction of the ventricular myocardium is going to cause the pressure to skyrocket. So this big increase in pressure here happens during isovolumetric contraction. So, as that occurs, the pressure inside the ventricle is going to go up and up and up until the pressure in the ventricle is now higher than the pressure in the outside arteries. If we're talking about the right ventricle, the pressure there is now higher than the pressure in the pulmonary artery, and if we're talking about the left ventricle, the left ventricular pressure is now higher than the pressure in the aorta. So, this is going to give us event number 3. So once the pressure in the ventricle becomes higher than the pressure in the arteries, the semilunar valves are now going to open up, allowing for that pressurized blood inside the ventricle to shoot out, and the stroke volume is going to be delivered. So the ventricle will start to deliver blood out into the arteries. As that blood is delivered, the pressure is going to start coming back down, and eventually, once again, we get to the point where the pressure inside the ventricle falls back below the pressure in the arteries. So that will produce event number 4 here, in which the semilunar valves will close, and that is going to produce the second heart sound. The first heart sound was the closing of the AV valves. So now that the semilunar valves have closed again, we are back to the point where both the AV and the semilunar valves are closed. So this is going to cause the pressure to come way back down in the ventricle, and this is what we refer to as isovolumetric relaxation. So once again, isovolumetric refers to the fact that the volume of blood inside the ventricle is not changing, and that is only going to be possible if both the AV and the semilunar valves are both simultaneously shut. So our biggest drop in pressure happens during isovolumetric relaxation, and our biggest increase in pressure happens during isovolumetric contraction. As this relaxation occurs and as the pressure inside the ventricle starts to fall, again, we get to the point where the pressure in the ventricle falls back below the pressure in the atria. This will cause our final event here, event number 6, in which the AV valves are now going to open up, and that allows us to set back up for our next round of the cardiac cycle. The AV valves open and the ventricles will receive the end diastolic volume from the atria. After the ventricles delivered their stroke volume right here, the volume inside the ventricles went down from approximately 120 to approximately 40, the end systolic volume. So now if we want to have another round of the cardiac cycle, the ventricles need to fill back up with blood. And in order for that to happen, the ventricular pressure has to fall below the atrial pressure so that blood can flow from high pressure in the atria to low pressure in the ventricles. So I hope that helps. So this is looking at the cardiac cycle from the perspective of just pressure. Keep in mind, you're also going to want to be able to simultaneously consider what's happening here in terms of things also like the volume of blood inside the ventricles and also the electrical activity of the heart by looking at an EKG.